if f is continuous and differentiable, real valued function defined on the open interval -1, 4 such that f of 3 is equal to 5 and f dash of x is greater than or equal to -1 for all x, find the greatest value of f of 0. Is it 3? Is it 4? Is it 5? Is it 8? Is it 11? Please go through this question. Okay, so let's solve this. Probably you can take a minute or so in reading it and working on it. Okay, I hope you have got this solution. So let us see how to do this. Now, foremost, we will have to use this powerful theorem called as mean value theorem. What is the statement of this mean value theorem? If f of x is defined, so the function has to be defined, and if f of x is continuous, where in the closed interval, so the function has to be defined and the function has to be continuous, and the function f of x is continuous in the interval, and if f of x is differentiable in the open interval. Now this is closed interval for continuity, open interval for differentiability. Okay, then there exists a c present in the open interval a comma b such that f dash of c is going to be f of b negative f of a divided by b negative a. Right, so indirectly these are the requirements to obtain a slope of a function. So that is the understanding. Now this can have many philosophical interpretation. I don't want to go into all that, but this is a powerful theorem when it comes to determining the function's differentiability and the slope and its continuity. Okay, having mentioned all this, why do we need to have mean value theorem's support? Because we are talking about a function which is continuous and differentiable in the interval -1, 4, and f of 3 is given as 5 and f dash of x is given as greater than or equal to 1. So we have to transfer this statement for this function. So given that f of x is continuous in -1, 4, so let me draw the number line. You have -1 here, you have 0 here, 1, 2, 3 and 4 is over here. Now we are given value for this point 3. Okay, so from -1 all the way to 4 the function is continuous and differentiable. So that is a very important point we will have to know, and we will have to get the value of f of 0. Okay, so coming back, given that f of x is continuous in -1, between -1 and 4, so this means f of x is continuous in what? 0 and 3, right? Because 0 and 3 is actually inside -1 and 4. Okay, also we have already been given that f of x is differentiable, right, in this interval. So also f of x is differentiable in what? In the closed interval. Okay, 0 comma. Now what we are going to do is we are going to apply the concepts of mean value theorem along with the definition of the function given in the question. So we are given that f of x is continuous and differentiable. Okay, continuous and differentiable in the interval negative 1 comma 4. So if I were to apply mean value theorem, it means f of x is continuous in what? In negative 1 comma 4 and differentiable in negative 1 comma 4. So if I were to draw the number line, this is negative 1, 2, 3 and 4. So these are the 2 points given, but we need f of 0 and we have f of 3 is equal to 5. So we have to use these points. That means we will have to deal with a function which is limited to this interval 0 and 3. We will consider f of x to be continuous in the interval 0 comma 3. This is true. Why? Because 0, 3 falls within negative 1 and 4 and differentiable in 0 comma 3. So this means there exists a x element of 0 comma 3 such that f dash of x is equal to f of 3 negative f of 0 divided by 3 negative 0. So this is nothing but f of 3 is given as 5, f of 0. We will have to get this value for f of 0. So what is that going to be? That is exactly what we are required to be obtaining, right? So I just place it as f of 0 divided by 3. This is my f dash of x. But given, what is given? Given that f dash of x is greater than or equal to 1. So this means 5 negative f of 0 divided by 3 is greater than or equal to 1. So what is the meaning of this? This means 5 negative f of 0 is greater than or equal to 3. So this means 5 negative 3 is greater than or equal to f of 0. I'm just shifting the quantities. Okay, so the only thing is that we are given f dash of x is greater than or equal to negative 1. So that means I need to use negative 1 there. So if I were to use negative 1, this will become negative 3 and this will become positive. Okay, so that will be our new inequality. So from here clearly f of 0 is less than or equal to, because it's clearly less than or equal to there, 5 positive 3 is going to be 8. So the greatest value that f of 0 can take is going to be 8. So go back and check the solutions for this question. So these are the questions, or I would say these are the choices that are given. Is it A? No. Is it B? No. Is it C? No. Is it D? Yes, indeed.